Okay, so warm-ups for today. If you're at home, you can hit pause and give them a go. The first one is decomposing. So that's where we do this thing. That'll get you started if you're at home. So press pause and then give it a try and then come back to us. Okay, welcome back to us. So what do we want to do first on number one? What do we want to do first, Annika?
Factor at the bottom.
So let's factor the bottom so we know what we're working with here. X plus 5 and x minus 2. So that means my two denominators that were added, remember we're undoing an addition problem, were x plus 5 and x minus 2. And now our job is to figure out what a and b are. So we'll multiply everybody by x plus 5 and x minus 2. So when we multiply the left by both of those, they both cancel. That's the whole point of multiplying by both of them. The x plus 5s cancel, the x minus 2s cancel. And we're left with negative x minus 19. On the a term here, the x plus 5s would cancel, and that would leave x minus 2. On the b term, the x minus 2s would cancel, and that would leave x plus 5. Most of the mistakes on this problem that students make happen before or somewhere in there. Like most of the time, phrase it differently. If you make it this far, most of the time students are good. It's just factoring, remembering what to multiply by, and handling the canceling correctly, making sure it's clear on who cancels and what's left. Who cancels and what's left. If you make it this far, most of the time you're okay. What's a good value of x to pick? Yeah, I see. 2. Let's try 2. That'll wipe out the x minus 2. So negative 2 minus 19 equals a times 2 minus 2. There's why we picked 2. Plus b times 2 plus 5. Yay, great pick on the 2. That's gone. So negative 21 equals 7b. So b equals negative 3. That's nice. Most of the time for us, they're rigged to get integer answers. So if you don't get integer answers, you probably did something wrong. What's another good pick for x? Negative 5, because that'll wipe out the other piece. So if I plug in negative 5, oh, careful, negative 5 minus 19 equals a times negative 5 minus 2 plus b times negative 5 plus 5. And of course, there's why we picked negative 5. That one's gone. Careful here. 5 minus 19 would be negative 14. Negative 5 minus 2 would be negative 7. So a equals 2. Still not quite done yet because we want to answer the question in the form that is required. So I'm going to write a over x plus 5 plus b, which is negative 3, over x minus 2. Which I guess means I could have put this as minus 3 over x minus 2. The order doesn't matter either. You could switch the order of those and be okay. And lastly, if you really wanted to check that, you could get a common denominator and add, and you should get back to where we started. Almost no one checks these because it's like, man, I did all that work, I just hope I got it right. But once in a while, like one person per class, if they get finished and have time, they'll go back and check it and make sure they got it right. Questions on that one? By the way, test-inspired warm-ups, so you'll see something like that again. Both of these, for that matter. All right, number 2. What do we want to do first on number 2? Yeah, I see some of this going on. Yes, move it over. So 2 over x plus 4 minus 3 over x plus 2 is less than or equal to 0. And we're probably thinking zeros of top, zeros of bottom. I mean, I hope you're thinking that. I can see what zeros of bottom would be, but I can't really answer that question until I have one fraction. So I need to get this into one fraction, which means I need common denominator. So remember, this is where the kids in the back seat of the minivan are clamoring to have what the other guy has, our petty little denominators here. Yeah, well, he has x plus 2. Why can't I have x plus 2? Oh, fine. You can have an x plus 2. Of course, then the second guy says, well, wait a minute, that's not fair. He has an x plus 4. Why can't I have an x plus 4? All right, you can have an x plus 4. As long as it goes top and bottom, to make sure the fraction stays the same. Now we've got our common denominator. And we can worry about the numerators. So 2x plus 4. And then the main reason I picked this problem, that minus sign, make sure he gets distributed. Not just the 3, but the minus 3. So minus 3x minus 12. Negative x minus 8 over x plus 2 and x plus 4 less than or equal to 0. It's like, okay, all that work, now I can start thinking about inequalities and number lines and zeros and shadings and all the rest of the stuff. But I had to get all of that done first to make it one fraction on the left-hand side. Alright, so for the top, that's a little bit weird with that negative out front. So I should be a little more careful with this one. Negative 8 equals x, so x equals negative 8. Right. It's not that it's hard, it's just different than what we're used to. For the bottom, you can probably just look at them and say, well, x is negative 2 and x is negative 4. Those would make the zeros of the bottom. So there's my values that will go on the number line. Again, please, please, please put your values on the number line in the correct order, right? I mean, it's a dumb mistake, but it happens. So the smallest of those is negative 8, and then negative 4, and then negative 2. And yeah, those aren't spaced out correctly, but that's okay. This isn't for, perfect accuracy in terms of spacing and scaling. It's just to help me figure out where to shade. At negative 8, are we going closed circle or open circle? Why closed? All right, the equal to part of that means we'll do a closed circle for negative 8. What about for negative 2 and negative 4? Why open? Because they come from the bottom, so they're always open, because you can't divide by 0. And if x is negative 4, you're dividing by 0. If x is negative 2, you're dividing by 0. You can't do that. So bottom zeros are always open. Now, if I want to do this sort of the official way, I would need to pick a number on each interval and test them all. I don't really want to do that. So I'm going to test 1. Maybe I'll test 2, but let's test 1 and do the alternating rule. And if I'm going to test 1, it may as well be 0, because that's probably the easiest to test. So I'm going to test the factored form that we worked so hard to get, because it's easy to test. Although I guess the original would be easy to test as well. So if I'm plugging in 0, I'd get negative 8 over 2 times 4. And I want to know if that's less than 0? Let's see. So it's a negative number, and that's less than 0. So yes, we would shade over there. And then I can alternate off of that. So this one would be a no, this one would be a yes, this one would be a no. If you're confident in that, go with it. Like, why waste time? Or it's not wasting time, but why spend the time when you're pretty sure that's your answer? If you want to come back later after when you're through with the test, maybe you star this one while you're working through it to say, okay, I'm going to come back to that one and check another spot. You can. But in the interest of time, I'm going to say let's trust it. So our answers go from -8 to -4, and from -2 to infinity. So it's not cheating to use the alternating rule. Like, it's a perfectly acceptable thing to do. Do you remember the one exception to the alternating rule? If you're going to use it, you better know it. What's that, Annika?
It's like a square.
Yeah, if one of the roots is a double root, it won't alternate across there. So just use the alternating rule, but beware of double roots. All right, so flag that somehow in your notes, because you want to redo those again closer to test day, so that you'll know you'll be ready for those.